at MEP CAD Guru, one of the best institute near Guntur, Tenali, Vijayawada, Mangalagiri, Andhra Pradesh. 20 years of experience, faculty, quality education, value for money, 100% job oriented, 100% job assistance, lowest price, digital classes, site exposure, while learning, real life projects. Hands-on experience. Compressors used in heating, ventilation and air conditioning. Compressor is used to remove the heat-laden vapor refrigerant from the evaporator of the air conditioning systems. In layman term, the compressor compresses the vapor into a smaller volume at high temperature. The external drive compressor has a crankshaft that is driven by a pulley and belt system. An electric motor can also be used to drive it directly. The hermetic compressor has a motor which is sealed inside a housing with the compressor, hence a crankshaft seal is not required. There are basically 5 types of air conditioner compressor that are commonly used in the HVAC industry: reciprocating, scroll, screw, rotary, and centrifugal. Reciprocating compressor. The reciprocating compressor uses piston to compress the refrigerant driven by a crankshaft in a straight line back and forth motion. This rotary motion is achieved by the use of an electric motor, and the construction is quite similar to that of an automobile engine. The piston moves up and down inside a cylinder. Vapor from the suction line is moved through the intake valve as the piston moves downward. As the piston moves upward, it compresses the vapor refrigerant, which is then pushed through the exhaust valve into the condenser. The compressor may has more than one cylinder, which is also known as multi-cylinder compressor. The common ones are the 2-cylinder, 4-cylinder, and 8-cylinder compressors. Reciprocating machines are manufactured in capacities from 0.5 to 150 TR. Scroll compressor. A scroll compressor has one fixed scroll which remains stationary and another moving or orbiting scroll that rotates through the use of swing link. When this happens, the pockets of refrigerant between the 2 scroll are slowly pushed to the center of the 2 scrolls, causing the reduction of the volume of the gas. It is then discharged through the center port to the condenser. The advantage of scroll compressor is that it has fewer moving parts and less torque variation compared to the reciprocating compressor. This advantage is translated to a smooth and quiet operation. Scroll compressors have been used in commercial practice for systems that have capacity less than 30 TR. Screw compressor. The screw compressor uses a pair of helical rotors, where it traps and compresses the gas as the rotors revolve in the cylinder. In HVAC, they are usually used in systems with 20-ton capacity and above. The male rotor and the female rotor are built inside the cylinder. The low-pressure refrigerant enters one end of the compressor and the resultant high-pressure refrigerant is discharged into the opposite end of the condenser. Screw chillers are available in capacities ranging from 20 to 1000 tons and even higher from few manufacturers. Rotary compressor. The rotary compressor can be divided into 2 types. One has blades or vanes that rotate with the shaft. The other type has the blade which remains stationary and is part of the compressor housing assembly. In both types, the vapor from the suction line is drawn into the cylinder through the suction port. As the blade rotates, trapped vapor in the space ahead of the blade is compressed into high pressure gas, after which it is discharged to the condenser through the exhaust port. The number of blades can range from 2 to 8 in a single system. Rotary compressors are normally for small applications having tonnage up to 3. Centrifugal compressor. Centrifugal compressor is usually used in large capacity refrigerating system. In this compressor, the vapor is moved in a circular motion known as centrifugal force. An impeller, which is a disc with radial blade, spins rapidly inside this housing, causing the gas to gain velocity. A diffuser converts this energy into pressure energy and is then discharged into the condenser. The pumping efficiency increases with speed, hence this type of compressors are designed to operate at high speed. The main advantage of centrifugal compressor is that there are no valves, pistons or cylinders. The wearing parts that need attention are the main bearings, The centrifugal chillers are manufactured in capacities from 90 to 2000 tons. Selection criteria. Energy consumption per ton of refrigeration is highest with reciprocating machine followed by screw compressors. Centrifugal compressors consume the least power at full load operation. Operating costs at part load efficiency. Efficiency at part load operation is very important aspect of analysis. Overall economics on life cycle basis demand much more than the peak loading. One must look at how those loads vary on a daily and seasonal basis. Remember, a typical chiller operates less than peak loading more than 90% of the time. The screw compressor offer infinite reduction from 100% to 0%. That allows obtaining higher refrigeration capacity from the same machine and affords good part load efficiency. The centrifugal machine accomplishes the capacity reduction in stages. When building load decreases, the chiller responds by partially closing its inlet vanes to restrict refrigerant flow. While this control method is effective down to about 20% of chiller's rated output, it results in decreased operating efficiency. For example, a chiller rated at 0.6 kilowatts per ton at full load might require as much as 0.9 kilowatts per ton when lightly loaded. Since chillers typically operate at only a full load less than 10% of time, part load operating characteristics significantly impact annual energy requirements. The reciprocating compressor stepped capacity control is most efficient at minimum load than the twin screw compressor.